Talking about arithmetic progression, arithmetic progressions. From our whole level knowledge, we've talked about arithmetic sequence, or what we call AP and GP, arithmetic or linear sequence or progression. Under series, we are going to be talking about arithmetic progression. And at the end of today's class, students should be able to recognize and solve problems on arithmetic progression. And at the end of this episode, you should be able to solve the following questions. So, just take a look at the question. You can pause the video and give it a shot if you want to try. Yes, there's no big deal here. We've done it in our O-level mathematics or IGCSE math. Yes. Okay. At the end of this episode, you should be able to solve this question. All right. Let's kickstart the class with startup activity. Here are some questions for you. Please pause the video, and when you are ready to see the answer, play the video. All right. Thank you. Let me show the answer now. Here are the answers to those two questions. Yes. Congratulations to those people that got the answers correctly. Thank you for making attempts. But if you are not sure or how we come about this answer, this episode is for you. Come, let's discuss arithmetic progression. If you are given a sequence 2, 4, 8, let's say 6, 8. All right. I told you this is a sequence. A sequence is a set of numbers that have a specific rule that governs them. It's a set of numbers that has a specific rules that governs them. This is what they call sequence. But if there are signs, maybe plus sign or minus sign in place of the comma, then it turns to a series. For example, if I have 2 plus 4 plus 6 plus 8 plus ... This sequence turns to series. It can also be 2 minus 4 minus 6 minus 8, and they put minus ... It turns to a series. It's turned to a series. And it can even have a pattern of mixed sign. Yes, it can have like that, and it's plus ... So when you have a sign instead of a comma, a sequence turns to a series. For your level, I think that's the only thing you need to know for now. Some series or sequence have a common difference, like the example I have here. Any sequence with a common difference in the first difference, okay, is called a linear sequence, or you call it arithmetic progression. Any sequence with a common difference is called linear sequence or arithmetic progression. Like if you look at the sequence I gave here, the common difference here is 2. Yes, the common difference is 2. How about if I have 20, 15, 10, 5, and I have ... So what will be the common difference here? The common difference D will be minus 5. Minus 5. In this place, the common difference D is 2, positive 2. Any sequence with a common difference is called arithmetic progression or linear sequence. Okay? In every arithmetic progression, the first term, like we have here, the first term is always called A. Yes, and the second term we can call it U1 or U2, third term U3, fourth term U4. In some textbook, they call it first term, second term, third term. And the nth term will be tagged UN, or you call it TN, UN or TN. Okay? So the first takeaway here is any sequence with a common difference can be classified or recognized as arithmetic progression. Like the example I gave before, 2, 4, 6, 8, 6, 8, 2, 4, 6, 8, comma, dot, dot, dot. This is my first term, A, and this is my second term, U2, or I call it U3 or U4. And I can have the last term here, I call it UN. Now, if I want to get common difference, is the difference between the U2 and A. It will still be the same thing as U3 minus U2 is also the same thing as U4 minus U3. What am I saying? The second term minus the first term will give you the common difference. It will be the same thing. Let's check it out. For this one, 4 minus 2, 4 minus 2, which is the same thing as 6 minus 4. 6 is my third term, 4 is the second term, which is the same thing as 8 minus 6. Everything here will give you 2, 2. 2, 2. So I can write each of the terms in this sequence as the first term, which is 2, and we call it A. The second term, which is 4, I can call it A plus D. That was what gave us second term, which is our kini. If I want to write the next term, 6, it will be A plus D plus D, 2 Ds, which is A plus 2D. If I want to write the next one, which is the fourth term, 8, it will give me A plus 3D, A plus 3D. Okay? If you look at it closely, this is for example, if I want to write the sixth term here, the sixth term, which is U6, should be A plus how many D? You can see here that when it is U3, the D is 2. When it is U4, the D is 3. When it is U6, the D should be what? 5. Is decreasing by 1, 1. If I want to write U10, that is the 10th term, what will it be? Thank you, A plus 9D. If I want to write UN, that is the nth term, it will be A plus the number of that term minus 1D. The number of that term minus 1D. And that is the formula for calculating the nth term of an arithmetic progression. The formula for calculating the nth term of an arithmetic progression. So the common difference will always be U3 minus U2, or you say U5 minus U4, or you say UN minus UN minus 1. Okay, that is for common difference. If I want to calculate my nth term, we have gotten it from here as A, which is the first term, plus n minus 1D. N minus 1D. Now, you may also be asked to calculate the sum. The formula for the sum of an AP, sum of an arithmetic progression, AP, when you know the first term and the last term. will be n over 2 open bracket the first term plus the last term. The first term plus the last term. In a point or in a situation when you don't know the last term but you know the common difference, you can also have the sum to be n over 2 the first term plus the formula for this. Yes, so you have a n minus 1 d. Okay, substituted for the nth term. I substituted for the nth term. We can see from here that this is the formula for the nth term, that is un. So a plus a, this formula can be reduced to n over 2 open bracket 2a plus n minus 1 d. This is another formula for calculating sum of arithmetic progression when the number of terms is known and first term and the common difference is given. If you only know the last term, the first term and the number of terms, you can use this. And in some occasion, we can calculate number of nth term by using sum of the nth term minus sum of the subsequent one. We normally use that. Yes, so these are the formulas you need to know about arithmetic progression. Common difference, which is the T2 minus T1, or U1 minus, that is your U2 minus A, or U3, that is third term minus the second term. You can also know the number of terms in a sequence by using un is equal to a plus n minus 1d. The sum, when you know the number of terms, the first and the last, n over 2 open bracket a plus un. And when you are given common difference and the first term, n over 2 2a plus n minus 1d. Let's take a practical question and practice this. I know you know this and it's common. All right, let's check this. Let's check this out. I will just solve few questions to refresh your brain from your O-level mathematics. I've told you when you have positive sign with a particular number, you know that is a series and you do it normal way. The first question here asks me to find the number of terms and the sum of this arithmetic series. Why is it called series? Because of the sign. Which one should I do, A or B? Okay, I will do B, you do A for me. So for me to do B, my first term is 152, my second term is 149, my third term is 146, and my last term is 50. So my last term is 50. If the last term is 50, then we can find the nth term by using the formula. Okay, what is the formula for the nth term of a sequence? This is equal to, yes, a plus n minus 1d. So I need to know my d first. How will you get d? D is equal to u3 minus u2. So 146 minus 149. I can also use u2 minus the first term, and this one should give me what? -3. Okay, now that I know that it's -3, I can find my nth term. The nth term is 50. Okay, let me change my marker. Nth term is 50. So I have 50 equals to my first term 152 plus open bracket the n I'm looking for minus 1, and I have -3 here. So if I have 50, I have 152, then minus 3n plus 3. I expanded this. So when I add this to this, I have 155 minus 3n is equal to 50. If I collect like times, 3n is 155 minus 50. And I think you are following. 3n is equal to, when you take away this, it will be 105. Yes, 105. If I divide 105, second question number 2. Okay, here I'm doing only question 2a. So I'm to find the sum of the 17th term of this series, 5 plus 12 plus 19. My first term is 5, my second term is 12, my third term is 19, okay, and my n is 17. So to find that, I did not know the last term, so let me just use this formula straight up. N over 2 bracket 2a plus n minus 1 d. So I need to know my d, common difference. The common difference is u3 minus u2, so which is 19 minus 12, and I think that should be 7. Okay, that is 7. Let's substitute. X17 will now be 17 over 2 bracket 2 times the first term, which is 5, plus 17 minus 1, 7. Okay, I'm going to have 17 over 2 bracket 10 plus 7 times 16. So I can put this into my calculator straight up. So putting this into calculator straight up, my x17, sum of the first 17 terms, will give me 1037, and that's how to do it. Thank you very much for watching this episode. You can do the following. Here are questions for you to practice. Exercise 6C. So just do the questions there, and we will see in the next episode. See you next class. Bye.